Hi, for this video what we're going to do is we're going to find the correlation coefficient using the TI-84. The correlation coefficient tells us how linear the data points are, and if you look at this formula that we have right here, the formula is something that does take a lot of time if you have to do hand calculations, but I want you to understand what your calculator is doing when it does find R for you. So if you look at this, the way that the formula would work, if you were to do hand calculations with this, which would take you a very long time, especially if you have a lot of data points, you would have to first go through and multiply your x times y and create a third column that has x times y. We would have to have another column for x squared where we square all of our x values, and a column for y squared where we square all of our y values. After we found x times y, we would then have to sum that value, sum that column, and plug it in here. We would plug in the sum of all of our x values here, the sum of our y values. These are different from each other. This tells you to find the sum of the column that has x squared in it, where this one tells you to square the sum of your x column. And then you would do the same thing for y. So this is something that takes a very long time to do hand calculations with, so you don't want to do that. So most of the time in the real world, we would use some kind of technology. In a classroom, it's easiest to use our graphing calculators, and our graphing calculators do find this for us. So what I'm going to do is I'm going to pull up the TI-84, and we'll walk through step by step. Your calculator does default to have the diagnostics for statistics turned off, so you will have to turn those on. I will show you in a minute how to do that. And what we are going to do is we're going to hit Stat and Edit, and this is where we're going to put all of our information in. I have some information in here that I don't want, so to get rid of it, I would highlight on L1 and hit Clear. Don't hit Delete because that gets rid of it. If you do get rid of it, just hit Stat Option 5 and then hit Enter. It'll say Done. It'll bring back any lists that you accidentally delete. So I tend to use L1 and L2. So the first thing that we would do is just enter in our data points. So let me just quickly do that. Always check to make sure that you put your data points in correctly and that everything matches up, especially when you're dealing with bivariate data. Because if you don't match up your coordinates correctly, then it's going to throw off all of your calculations. So let me just get these in here. And then I always just go through and check to make sure that everything lines up correctly. So I check all of my points individually to make sure that I didn't mistype and accidentally miss something somewhere. So once you have everything done, it's always a good idea to take a look at what the picture looks like, because the correlation itself is not a good representation of how linear it is, because you could have something that looks more exponential in form, or it has a slight curve to it that you wouldn't want to use a linear equation for. So the correlation coefficient in and of itself is not enough to help you decide whether the data is linear or not and whether a line is a good fit for it. So what we would do to check that is we're going to go ahead to do a scatter plot with this. So we're going to go to second y equals, and all of my plots are turned off. So I'm going to go to plot 1. And I'm going to turn it on, and I'm going to go down to the next row, and I'm going to choose the scatter plot. You always want to make sure that you pay attention to where you put your data. Your calculator defaults to L1 and L2, but if you put your data in L3 and L4, then you have to change this. So you could change this by doing second list. You can select it if you used a different one. I used L1, so I'm just going to leave it there. And then after you have everything set up, the mark just allows you to change what it looks like. So if you want it to display differently, you can. If you wanted to choose a different color, you can always choose a different color. And if you hit graph, it's not going to show anything because of the fact that right now our data points don't fit. So the easiest way to get there is hit zoom and option 9. Zoom 9 is our stats screen, And you can see that for the most part, this is linear. There's one point that kind of doesn't fit in with the rest of the data. This is something that is going to influence our correlation because it's further away from a line. The rest of these really are almost perfectly linear. That's a very, very strong correlation. I would definitely use a line to display this, but it is important to notice that this point is kind of doesn't fit in with the rest of them. If you wanted to see what that point was, you can click trace. And you can see that it's at 45,132. So this person didn't quite fit in with the trend of all the rest of them, but I would be very comfortable fitting a line to this data set. So now let's find the actual correlation coefficient. And the correlation coefficient just tells us basically on average how far each of these points are from the line of best fit. So it kind of gives us a number so that we can compare how well the line fits the data. The closer it is to +1, like this one would have a positive correlation because it goes up from left to right. So if it went down from left to right, it would have a negative correlation. And the closer your R or your correlation coefficient is to 1, the more linear your data is. The further from 1 it is, the less linear your data is. So to get the correlation coefficient, once you've checked your scatter plot to see that a line is appropriate, we would find our correlation coefficient. And our correlation coefficient, to get there, we would go to Stat, Calculate, and you can either use linear regression in this form. This is more the typical algebra form of linear regression. Most stats textbooks use this linear regression form, so it doesn't matter. Right now we're not coming up with the equation, we just want R. So I'm going to choose option 8. And I have some information in here. I don't want a frequency list, so I'm going to clear that out. And I'm not going to store the regression equation because I'll do that in another video. But once I run this, if you notice my R didn't come up, that's because I forgot to turn my stat diagnostics on. I just wanted to show you what it would look like if you don't turn your stat diagnostics on. So if you have a newer graphing calculator, you bought it in the last like 5-6 years, you should be able to go to the mode and turn your stat diagnostics on directly from your mode. So again, I hit the mode button. And what we're going to go down is we're going to go down to where it says stat diagnostics, and we're going to turn that on. Okay, if you don't have this option, the other option, like I know if you have a TI-84, you would do the second catalog, and you would actually hit the green D. So notice there's a green D right here, and I would just scroll all the way down. This is the old school way. This is the way that I learned how to do it because I didn't have the menus. You would hit diagnostic on, and you actually have to hit enter until it's done. You don't have to do that if it was in your menu. Okay, just to show you what this did is now if I go back to second, enter, I'm pulling back up the linear regression that I did before. And notice now it gives me R and R squared. So the R value right here is my correlation coefficient. So I would say that R is approximately 0.9677 if I rounded it. So this is my correlation coefficient. Since that value is very, very, very close to 1, this shows that there's a very strong linear relationship, and it would be very, this line of best fit would be a good representation. If you're curious as to the R squared is your variance, and it's telling you that 93.6% of the variability in this data is explained by this equation. And R just comes from taking the square root of R squared, but this is your variance or variability of your scatter plot. So with this, like I said, what your calculator did to do this, remember that all you had to do was hit enter and it quickly gave you an answer. I know that I showed you guys like a lot of other things, but had you done hand calculations for this, it would have been very time consuming. If you have any questions, please make sure you let me know. And as always, thanks for watching.